Okay, hello guys. Welcome back to Tough Math, a YouTube channel that features solutions to some math competition problems given in the past several years and given locally and or internationally. So our problem for today is a sequence A sub n of 300 integers consists of 55 terms that are equal to -2, 87 terms that are equal to -1, 96 terms that are equal to +1, and 62 terms that are equal to +3. What is the sum of all products AI times AJ, where I is less than J and I is at least 1 and J is at most 300? Okay, so we let this sum be denoted by S, and this is equal to the sum of the product AI times AJ, where I is at least 1, I is less than J, and J is at most 300. Okay. Without loss of generality, we may rearrange the numbers in ascending order. That is, we let x sub 1, x sub 2, x sub 3, and so on until the 55th term to be equal to -2. And then x sub 56, x sub 57, and so on until x sub 142 be equal to -1, and then x sub 143, x sub 144, and so on until x sub 238. They are all equal to +1, and then x sub 239 equals x sub 240 until the last number, which is x sub 300, and they are all equal to +3. So here we have 55 terms, then we have 87 terms, we have 96 terms, and we have 62 terms. Okay, so then the sum, or S, which is equal to the sum AIAJ can now be written as the sum of xi xj. Okay, so originally the numbers are called a sub i's, but after the rearrangement they are now called x sub i's. So here I is still at least 1 and I is still at least j, less than j, and j at most 300. Okay, this one is before the rearrangement. While this one, that expression is after the rearrangement. Okay. And so this sum is equal to since they have now been rearranged and the first subset of terms or numbers are all negative 2's and there are 55 of them, so we take 2 out of 55 and then multiply them together, so we have negative 2 squared. Then we take 2 elements from the second subset. There are 87 of them. Take 2 and they are all negative 1, are both negative 1, so we have that. And then 96, take 2 of them and they are both 1, so we have times 1 squared. And then from the fourth set of numbers we have 62 of them, take 2 and they are both 3, so we have 3 squared. And then we take the number from the first set, it's they are all negative 2's, and then from the second set they are all negative 1's. There are 55 negative 2's, so times 55, and there are 87 negative 1's. And then negative 2 from the first set, positive 1 from the second set, third set. And then we have 55 from the first subset, 96 from the third subset, and then we add minus 2 times 3. There are 55. Yes, there are 55 from the first, and there are 62 from the fourth subset, plus we have negative 1 from the second subset, and then positive 1 from the third. There are 87 from the second, there are 96 from the third, plus negative 1 times 3. There are 87 from the second subset. There are 62 from the third. And then negative 1 and then 3. And then from the third you have 1, and then from the last set you have 3. There are 96 ones, and there are 62 threes. How many terms? 1, 2, okay. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10. And from this we have 5,940 plus 3,741 plus 4,560 plus 17,019 plus 9,570 plus negative 10560 plus negative 20460 plus negative 8352 plus negative 16182, and then plus 17856. And when you add these numbers, we get 3,132. So this is the desired sum. This is the okay. So that's it for this video. And this is the challenge that I will be leaving you. How many integers between 80,000 and 89,999 have exactly 2 identical digits? So I challenge you, or challenge yourself, to solve these problems before watching the next video, because the next video will contain the solution to this problem. Also, I would like you to think about this. The Lord may not come when you want Him to, but He will always be on time. This is according to Alex Haley's grandmother. Alex Haley is the author of the book Roots. So that's it for now. Thank you for following our channel and listening to the discussion. I hope you enjoyed the discussion and you learned something from it. So goodbye for now. Be well, and may God bless you.